Once again, good morning. We'll now discuss lesson 2.5. Lesson 2.5 is a culmination of chapter 2. We have discussed about the introduction to quadratic functions, the graph of the quadratic function, which is a parabola, and the shifting. We move left, right, up, down, narrow, and wider. And yesterday, we have learned how to find the equation of a quadratic function. And today, for lesson 2.5, we will solve problems on quadratic functions. Now, let's have, I think we all have 3 short problems. To start with, let's recite today's memory verse. Today's memory verse is found in Philippians 4, verse 13. It says, I can do all things through him, through Christ, who strengthens me. And in the term of problem solving, your MVCA boosters is also related to this, asking for strength. In dealing with everyday problems, we need to ask God for strength. What does our memory verse in Philippians 4, verse 13 remind us? You'll have a very brief reflection on that one. And for our meet our targets, at the end of this lesson, you'll be able to solve problems involving quadratic functions. Actually, we are nearing the end of our module. You can open your module in page 80. We are down to the last, how many pages? The last 5 pages? Yes, the last 5 pages of our first quarter module. I told you a while ago that this lesson is the last lesson for the first quarter. And on Monday, you will submit all your workbooks too. And on Tuesday, we'll start with the second quarter. Now, here are some real-life applications for quadratic functions. You see, these are beautiful landmarks. Also a bridge, the movement of a fountain, the M in McDonald's, when you shoot a ball, also in a rubber swing, or it can be in a Ferris wheel, and even the reflection or the light, the path of the light that we see. If you notice, most are what we call this are parabolic, and our performance task will also be about parabolic art. I'll discuss that one afterwards. Now, to solve for different problems in quadratic functions, we remember the vertex form or the vertex formula. Now let's start with the first problem. In problem number 1, it says, the sum of 2 integers is 30. What is the product of these 2 numbers? Now, what is missing? We say that the 2 numbers are missing. Now, we don't know what the numbers are. So let's start to represent. We say, let x be the first integer or the first number. If the sum of 2 integers is 30 and the first is x, how do we write the second number? Here, let me have an illustration with you. For example, these are 2 numbers, the first and the second. If the sum of 2 numbers is 30, and this one is x, now how will I write the other number? For example, if the other one is 5, you know the other one is 25. How did you write 25? That's the sum minus 5, the first. So we will have the same pattern in representing the second number. So if the first number is x, then the remaining number will be the sum minus the first. So the second number, or the second integer, is 30 minus x. That is our second integer. Now, what does the problem say? The problem is asking us of the maximum product. What is the maximum product of these two numbers? So what will we do? We will multiply. The function of x will be the product of these two integers. So the first multiplied by the second. We will distribute. We have 30x and the other is negative x squared. So this is now our equation, f of x. Remember, the problem is asking us of the maximum product. How do we solve for the maximum product of two numbers? Here, in the parabola, this is your maximum, right? If the parabola opens downwards. Or if it opens upwards, this is also your minimum. It means the lowest point, and this is the highest point. And we call this our vertex, our HK. So to solve for the maximum or to solve for the minimum products, you'll solve for the vertex. Now, how to solve for our vertex? You go back to lesson 2.2. In lesson 2.2, it's about the graph of the parabola. I'm sorry, there are so many messages and calls. So we'll solve for the vertex. What is the formula for the vertex? That's negative b over 2a for h, and for k, that's 4ac minus b squared over 4a. Let's solve. Remember, our a is negative 1, our b is 30, and our c is 0. Let us solve. Ready? Negative of b over 3 times, not 3, 2 times a. Why there? 4, a is negative 1, c is 0, minus b squared, 30 squared, over 4 times a. We have negative 30 over negative 2. So our h is 15. Remember, negative divided by negative is positive. How about for the other one? 4 times negative 1 times 0 is 0. Minus 30 squared is 900 over negative 4. Negative 900 divided by 4, negative 4 is 225. So H and K. So it means that our maximum point is found at 15, 225. What's the question again? What's the maximum product of these numbers? Here, how do we interpret our HK? Remember, 15 is your X, while this is your Y. If you have that in this equation, remember f of x is the same as your y. So the maximum product is 225. What are the values of x? What are the numbers? 15. And what is the other number? 30 minus 15. So still 15. So we say our two integers are the two integers that are being multiplied are 15 and 15. The sum is 30, right? And what is the maximum product? The maximum product is 225. But if your question will ask you of two unique numbers, not the same number, then it's not 15. We can have another number like 14 and 16, or that is the next highest number. But since it's only generic, then we can have 15 as the answer. That's for the first problem. Any questions?